Hello, this is Wim.
And it's Stuart.
We're back. Today we're going to talk a little bit about remote sensing of the urban environment and the urban landscape. As you know, urban landscapes are very diverse. You see lots of different things and they are very complex quite often. So remote sensing can shine some light on the urban landscape because you get this synoptic view and you can really determine and look at different things with optical, with thermal, with a variety of different sensors, and look at a lot of the details in an urban environment that is probably very different from when you look at a larger landscape. So the resolutions are very different quite often when you look at a urban environment than when you look at kind of more of a global scale or regional scale assessment of something like global change. So the urban environment, urban landscapes have been observed from space, from the space shuttle, from other satellites to kind of look at the lights that they see from space. That's where you see the distribution of urban settlements. But at the same time, there's a lot of planning going on in an urban environment where you need a lot more detailed information related to flooding, related to risk, related to a variety of different things that are important for insurance companies quite often as well. So a little bit of a different approach. And for this, we kind of quite often make land cover classification maps. And for that, Stuart has been working on that a lot.
Right. We've spent a lot of time doing urban classifications, and one of the things that I think you'll see in the work you do is the complexity of the spectral signatures from urban environments. One of the things that students always note is that how come the dark rocks and the pavement, the blacktop pavement, are classified in the same class? And that's because dark rocks and blacktop pavement are spectrally the same. And so doing urban classification can be difficult. And one of the things that you really need to remember is the relationship between the scale of the imagery that you're using and the classification system. You'll be learning in this chapter about a hierarchical classification system that's designed to be used at high resolution imagery and low resolution imagery. And having that ability to see what can and can't be named and classified is an important concept for you to remember.
And then from that perspective too, if sometimes, like Stuart said, if tar and volcanic rock are looking the same, there might be another sensor that you might bring into that as well. Like maybe a LiDAR sensor gives you elevation information, so the rocks may be having a different kind of environment and elevation than the pavement will have. So a lot of these things you might not be able to do with just one sensor. So you start fusing some data sets, and we have been doing that in the past too for mosquito habitat assessment in an urban environment, where we actually had to provide use both LiDAR and high resolution 1 meter spectral reflectance data. So anyway, lots of opportunities to learn more about the urban environment in this chapter, and I'm looking forward to see your work regarding this.
Take care.
See you later.